Okay, so solving by elimination. So it's a second algebraic method. You need to be able to know both of these methods. So on a test, I might say solve by elimination or solve by substitution. So either method. Okay, basically our goal is to make our coefficients, one of the coefficients for one of the variables the same. And why would we do that? Well, we're going to be adding and subtracting equations together. So, for example, if our coefficients are the same, I'm just going to give you a random example. How could I get x to cancel out? Would I add these equations together or subtract them? If the signs are the same, we're going to subtract, because then 2 minus 2, what would that equal? 0. That would our x would cancel out. And then 4 minus 10, negative 6. 12 minus a negative 16. What happens if we subtract a negative? We're going to add. So it becomes a positive. If you're 12 minus a negative 16, be 12 plus 16. So it becomes 28. And then divide both sides by negative 6, and we get our x. So we can add or subtract our equations together to eliminate a variable. But in order for that to happen, we need one set of the coefficients to be the same in order to do that. So let's look at the first problem. A system of linear equations defined by the equation 3x plus 4y equals 29 and 2x minus 5y equals negative 19. Do we have any coefficients the same? No. If you look at the x's, are they the same? No. And we look at the y's, are any of them the same? No, not yet. So we want to make them the same. And how we make them the same is we basically can change the equation by multiplying it by a number to make it the same number. So who do you want to make the same? Let's use x the same. So 3 and 2, we need to find the lowest common multiple of 3 and 2. 6. So we want to make both our x's a 6. So I'm going to number this equation 1 and equation 2. What would I have to multiply equation 1 by to make it a 6? 2. So we're going to multiply equation 1 by 2. So I'm going to write 2 times 3x plus 4y equals 29. The whole equation, we're going to multiply it by 2. Because we want to make them both 6x. And so 3 times 2 would make 6. What times 2 would make a 6? 3. 3 times 2 would make a 6. So we're going to multiply the whole second equation by 3. Now, a little hint, what we can do every time is just switch the numbers. The coefficient of the second was 2, so we're multiplying the first equation by the 2. The second equation is a 3. Sorry, this guy's a 3, so we're going to put them down there, right? If we just switch them, they'd be the same number. So that's a hint you could do. It doesn't have to be that way. We can also use an LCM. So let's change our equations. So we can multiply the whole equation by 2. What does it become? That first one. 2 times 3x, 6x. 2 times 4y, 8y. And 2 times 29, 58. Okay, how about 3 times 2x? 3 times 2x. 6x. 3 times negative 5, negative 15y. And don't forget the coefficient. The common mistake is forget to multiply the coefficient also by the 3. What's 3 times negative 19? Negative 37. Now these are still, 57, of course. 57. This was a 58. Okay, now do we have the same coefficient for x? Yeah, they're both 6's. Now, if the coefficients are the same and the signs are the same, so same coefficient and sign, and same sign, we're going to add or subtract? Subtract. We're going to subtract. So when the signs are the same, you subtract. I'm going to show you with subtraction. I'm going to show you with addition. Show you both methods. I like to use addition because with addition, you're less likely to make a mistake. Okay, so first one. Let's add these two together. Oh, so sorry. What are we doing? Subtracting, right? Same sign, subtraction. 6x minus 6x. 0, it's gone. Now be careful. 8 minus negative 15. Positive 23. Where 8 minus a negative becomes 8 plus 15, so 23x, or y. And then 58 minus negative 57. 115. Right, so you could even type that into your calculator if you needed to. So 58 minus a negative 57 gives you 115. Okay? All right, next step. Divide both sides by 23. And how many times does 23 go into 115? 5 times. Y equals 5. Now that's going to be the only part that's different from yesterday's lesson. The rest is going to be identical. So once we've made our coefficients the same and then add or subtract, after that, everything's the same. So our first step here, our next step here would just be sub y equals 5 into either equation. So we're going to sub y equals 5. Choose an equation. 1 or 2? 1, okay. And we can either use our new ones or original. I like to use the original. So because the numbers are smaller. Into 1. So we're going to replace this just like yesterday. 3x plus 4 times 5 should equal 29. So then 3x plus 20, s equal 29. The next step, putting x by itself. Subtract 20. What's 20 minus 29? 9. So x equals 3. And then our check is the same idea as yesterday. So if we subbed into equation 1 here, we're going to check with which equation? Check with 2. I should almost call this, I don't know if this is going to mess up your notes, but B, C, D. Okay, so check with 2. Our 2 equation was 2x minus 5y equals negative 19. So you know how to do this drill. Same thing as always. So we should have 2 times 3, which is 6, minus 5 times 5, or 25, should equal 19. Negative 19, sorry. And that does equal negative 19. So it's not that much different. Lots the same, just that first step is a little different. No, sorry, that's a negative 19. It's supposed to be a negative there. Just looks like, sorry, it attached itself. There you go. Okay, so that's using subtraction, is if the signs are the same. Let's try one where we're going to make the signs the opposite so that we can add. Okay. So I'll show you the next one. If it says solve and check, yes. And your written response will all say solve and check. So on your multiple choice, nope. The written, yes. Okay, let's look at this guy. 6a plus 5b equals 24, and 4a plus 3b equals 12. Now, it doesn't matter who we make the same. We can either make our a's the same or the b's. So choose, look at the numbers. So 6 and 4, and 5 and 3. Who would you, I mean, ultimately, 4 is not a multiple of 6, and 3 is not a multiple of 5, so we're going to have to multiply both equations by something in this case. So which one would you like to work with, the x, the a, or the b? Okay, so a it is. It doesn't matter. It doesn't matter. We're going to choose A. It's A. So we're going to make the A's the same. Okay? Sorry. Now, 6 and 4. Let's use lowest common multiple. What's the lowest common multiple of 6 and 4? What's the lowest number that both 6 and 4 will divide into? No, that they'll divide into. 12. The lowest common multiple of 4 and 6 is 12. Now, you could also make them both 24. So multiply the first by 4 and the second by 6. But we can keep our numbers smaller by turning them both into 12s. So what would I have to multiply the first equation by to make it a 12? A 2. 6a plus 5b equals 24. What would we have to multiply the second equation by to make the a a 12? 4 times 3. Now, I want to make opposite signs. I want to make one of them a negative so that we can add. So I'd like to do an example where we add instead of subtract, because with addition, we're probably less likely to make a mistake. So how can I make one of them negative, a negative 12? Shoot, negative 2 or a negative 3. So which one would you like to make a negative? Sure. Do the 3, as the first one said. First come, first serve. Okay, so let's multiply the first equation by a 2. 2 times 6, 12a plus 10b equals 48. Don't forget to multiply your constant as well. Negative 3 times 4, negative 12a, negative 9b equals a negative 36. So now, if we have the same coefficient, opposite sign, we are going to add. Same coefficient, opposite sign. Now, you could have also switched one of the signs after. So just a little side note, if I multiply the first by 2 and the second by positive 3, 6a plus 5b equals 24. And then 4a plus 3b equals 12. So say I multiplied them both by just the 2 and the 3, positive. Whoops. 6 times 2, 12a. So same equations here. And then 12a plus 9b equals 36. If you want to instead of subtracting, we can switch one of the signs on one of the equations and then add. So I could just go make this a negative, this a negative, this a negative, switch our signs, and then you can just add. Right? Switch all your signs, which is really what we did here. We multiplied everything by a negative. Same idea. Okay, let's add 12a plus negative 12a. 12 plus negative 12, because we're adding 0. We're adding because the signs are opposite, same numbers. And that's our goal. We want one of them to cancel. That's what we're trying to do, because then we're only left with one variable. What's 10 plus negative 9? Just a 1, 1b. 48 plus negative 36, 12. Done. Love when that happens. B is 12. Now, so we multiplied everything, then we added or subtracted. Now our next step, sub b equals 12, choose an equation. Let's just go into 1, check with 2. Okay, so 6 times a plus 5 times 12, b is 12, has to equal 24. 6 times a plus 5 times 12 is 60 equals 24. Then what's next? Subtract 60. We want to get a by itself, so move the constant. 6a, 24 minus 60, 36. Divide by, negative 36. Divide by 6. A is negative 6. So because we subbed into 1, now we check with 2. Yep, because we subbed into 1 here. And our last step. 4a plus 3b has to equal 12. 4 times, what's a? Negative 6 plus 3 times 12 has to equal 12. And we have negative 24 plus 36 equals 12. Okay, so I'd like you to try the next one on your own. Remember, we don't always have to multiply both equations by a number. We can just change one of them. Because looking at our next one, look at our numbers, 3 and 6, 4 and 5. Who should we make the same? X. To make them the same number, what could we do? Times 3 by 2. Is 6 a multiple of 3? Yeah, so we could just double this equation and then our x's are the same. So we don't always have to change both equations. Sometimes we only one. Okay, so I'd like you to try this one on your own. For consistency's sake, let's all make our x's the same. However you want to make the x's the same, you go ahead. So you can multiply it by 2 or negative 2 if you want to do opposite signs. Or if you really like to just switch the numbers, multiply the first by 6, the second by 3. You're going to have bigger numbers, but you'll get the same answer. So you could always just switch them as well. 6 and 3. So go ahead, eliminate the x. So make the equations the same x. Okay, now some of you might have done 3 and 6. I'm just going to multiply the first equation by 2. If you want opposite signs, then you would multiply it by negative 2. This is why addition trumps subtraction. It's because of these mistakes. So making them opposite. So 6x plus 8y equals 22. And then 6x minus 5y equals negative 4. Now you should have subtracted if you did it this way because the signs are the same. Now in order to eliminate, if you want opposite signs, take one of your equations and just switch all the signs. So negative 6x plus 5y positive 4. Then add. Okay, we add when the signs are opposite. So you should have had, this would have been gone. 8 plus 5 would have been 13y, not 3y. Because if you subtract the negative, you're adding the 5. And that's why if we just switch all the signs of one of the equations, then you can just add. 22 plus 4 is 26. Divide both sides by 13. Y is 2. Okay, because 12 plus 4. See, if you had a negative 4 here, you had to subtract. So 22 minus negative 4 is the same thing as 22 plus 4. Right? If you're doing 22 minus a negative 4, should be plus. Right. So my recommendation to all of you, especially if you're the type of person that makes little mistakes on tests, is always make them opposite signs so that you're adding. When you add, you're not going to make a mistake. Yeah, just make the bottom one. Switch the signs on the bottom, and then you're good to add. And then you won't make that same mistake. If you like subtracting and you don't make those silly mistakes, then go ahead and subtract. You can subtract it. So if you had 6x plus 8y equals 22, and then 6x minus 5y equals negative 4, you're welcome to subtract, but you have to be careful. 8 minus negative 5 is positive 13. 22 minus negative 4 is positive 26. So if you're subtracting, you have to be very, very careful. That's why I recommend addition. Just to change the signs of the bottom guy, make them opposite, and then go ahead and add. And then you're safe. Which is really what we did when we subtracted polynomials, right? When we subtracted polynomials, we changed it to addition by switching the signs. That's what we're going to do. Keep it safe. unless you like subtraction and you don't make silly mistakes. All right, so now that you have y equals 2, which one did you guys sub it into? 1? Okay, sub y equals 2. And so if you sub it into 2, check with 1. Sub it into 1, check with 2. Either way, you're going to get the same answer as long as you did your work right. So 3x plus 4 times 2 has to equal 11. Three x plus 8 has to equal 11. Subtract the 8. I get 3x equals 3. X equals 1. Okay, and so I subbed into 1, so I'm going to check with 2. 6 times x minus 5y has to equal negative 4. 6 times 1 minus 5 times 2 is 6 minus 10, which is also negative 4. Okay, so a lot of repetition from yesterday. Those first 2 steps are what's different, and then it's all the same from there, which is kind of nice. Okay, so turn the page. We're gonna do the first and the last word problem of the 3. We're gonna skip the muffin problem. Okay? All right, so next one. The muffin. All right, I would like you, on your own, come up with the variables and write the equations. Connor downloaded 2 orders of games and songs. The first song consisted of 5 games and 4 songs, which cost him $26. Second order consisted of 3 games and 2 songs, which was $15. All games cost the same amount, and all songs cost the same amount. Write in a system of linear equations, then determine the cost of one song and the cost of one game. So what did you use for your variables? S and G. And what did S stand for? Not just songs. What about the songs? The cost of one song and the cost of one game. Alrighty, your equations. Remember, each sentence is usually an equation. So when it said the first order consisted of 5 games and 4 songs, it's $26. What was our equation? 5G plus 4S equals 26. Second equation, second order consisted of 3 games, 2 songs, $15. 3G plus 2S equals 15. All right, so who do we want to make the same? S or G? S. Okay, let's use S because only one equation would have to change. Can we make the second one? Can you make a 2 into a 4? Yeah, by multiplying it by 2. Let's multiply it by 2. So the first one we're going to keep the same. Now, right now they're the same sign. So if we want to make them opposite signs, instead of just multiplying it by 2, what else could we multiply it by? A negative 2. So right now the signs are the same. To make them opposite, let's change this to a negative 2. This way, we can add. For some of us, that's probably a good idea. So first one stays the same. Next one, negative 2 times 3, negative 6, negative 2 times 2, negative 4, and 15 times negative 2, negative 30. This is what we want. We have the same coefficient opposite sign, so we can add. Yay. 5 plus negative 6. Negative 1G equals, and what happens with our S's? Cancel out. 26 minus 30, or plus negative 30, negative 4. We want a positive G, so we are going to divide by negative 1. G is 4. All right, almost done. It's tragic when you do all that work and you think you're done. We still have another variable to solve for. Where would you like to sub him into? 1? Okay, so G equals 4 into 1. 5 times 4 plus 4s has to equal 26. 5 times 4 plus 20 plus 4s equals 26. Our goal is to get s by itself. So who do you have to move first? The 20. It's a positive 20. Subtract it. We're left with 4s equals 6. And then divide by 4. Does it make sense that we can have a decimal? Yeah, because we're solving, s represents the cost. And money can be a decimal. So s equals 1.5, $1.50. Who are we going to check with? 2. So check with 2. And the 2 equation was 3g plus 2s equals 15. You could also use this new one, or you can use the original. No, check, you have to use the original. Sorry, check, you have to use the original. Because what if you made a mistake in changing the formula? All right, so 3 times 4 plus 2 times 1.5. What's 3 times 4? 12. 2 times that 1.5 is 3. 12 plus 4, or 12 plus 3, 15. Check. And last step, we write an equation. Therefore, the cost of one game is $4, and the cost to 4. Doesn't look like it. Let's try again. $4, and the cost of one song is $1.50. All right, skip the muffin. Let's go to the last one. Again, can you please come up with the formulas? Okay. Oh, skip the muffin. We're on the perimeter problem. Please come up with the 2 formulas and your variables. What are the 2 unknowns here? To determine the dimensions. Dimensions are length and width. In this case, you can just write length and just write width. You don't have to write a complete sentence because length and width are measurements in themselves. So we don't have to go, I don't know. It's the length, yeah. So let's go through this. Okay, so it says the perimeter of a rectangle garden is 17 meters. How can we make an equation out of that? What's the formula for perimeter of a rectangle? 2 times our length plus 2 times our width equals our perimeter. What's our perimeter? 17. Okay, that one you should kind of just know or get it off your formula sheet. Now the next one, did you guys get it? Triple the length is 2.46 meters longer than 5 times the width. So let's break it down. Yeah? Yeah, you could write that. Okay, so triple the length. How do we write triple the length? 3 times L. 3 times L. What does is mean in terms of mathematics? Equals. So 3L equals 2.46 meters longer than. What's longer than? Addition is longer than. 5 times the width is 5W. Now, longer than, whenever you have longer than or less than or more than, that always, whatever is longer than, is going to go after whatever comes next. So we should write this as 3L equals, instead of, so how would the next part work? 5W plus 2.46. The reason why it matters that it comes after is if it was subtraction, if it was less than. And it really matters because 2.46 minus 5W would be different than 5W minus 2.46. Well, we want to. So that's our equation given the original, right? But what's wrong with this? Does everything line up nicely? No, and it always has to line up. The equal signs have to line up, the L's, the W's, everything, the constants have to line up nicely. So we need to change these. The first one's okay. 2L plus 2W equals our constant. But the other one is not okay, right? We need the L and W on the same side of the equation so it lines up nicely. And so a lot of you already figured out how to do that. We need to move 5W. We're going to have to subtract the 5W over to the other side so that we just have our constant by itself. And that gives us, we write the 3 first, the L first because the L is first in the other equation, minus the 5W equals 2.46. Okay, now these are lined up nicely. Who do you want to make the same? Do you want to go ahead and solve that on your own? Okay, solve this one on your own using elimination. So it doesn't matter if you want to start by making the L's the same or the W's the same. You might want to use the W's because they're already opposite sign. So then you don't have to put in negatives there for you. Just change the first equation and second equation then. Go give it a shot. Doesn't matter, you should get the same answer, whether you make the L's the same or the W's the same. Oh well. Okay, so I'm going to make the W's the same. So in order to do that, here's my two equations. The nice thing about the W's is they're already opposite signs. So I'm going to switch the numbers. I'll put the 5 up here and the 2 down there to make them 10. And that happens to be also the lowest common multiple, but you could also use just the switching the numbers every time. And that will work. So I'm going to add because the signs are going to be opposite. Yeah. So we should get a 10L plus a 10W equals to 85. And then a 6L minus 10W should equal to 4.92. 4.92. So then, because my signs are opposite with my 10s, I'm going to add. Those will cancel, giving me a 16L equals 89.92. Divide both sides by 16. You should get L equal to, what did somebody get there? 5.62. That's correct. Yeah. And then we sub L equals 5.62 into either equation. I'll do it into 1. So 2 times 5.62 plus 2W has to equal 17, which gives us 11.24 plus 2W equals 17. Subtract 11.24, which gives us 5.76. Divide by 2, and that gives us 2.88. There you go. Now if I use 1, I have to check with 2 and always go to the original 2. So the original 2 was 3L equals 5W plus 2.46. Always the original when you do your check. 3 times 5.62 has to equal 5 times 2.88 plus 2.46. This is where a calculator is helpful. 6, 18, 15, 16.86. And then 16.86. Just gonna check. Good? It takes a while. If something went wrong, we can look through it, and I can help you with that. So at this time, homework is page 437, and these are the numbers. If you haven't finished your quiz, can you work on that now, and then I'll interrupt you during your homework time to mark it at some point. Okay?